Hi, my name is Carly Stratos, and I am a grade 12 Calculus and Vectors student. Today I will be demonstrating how to solve a problem from the McGraw-Hill-Ryerson Calculus and Vectors 12 textbook. The question I will be solving is question number 8 on page 139. A yogurt company estimates the revenue from selling X containers of yogurt is 4.5x. Its cost, C, in dollars, for producing this number of containers of yogurt is C of X equals 0.0001x squared plus 2x plus 3,200. A. Determine the marginal cost of producing 4,000 containers of yogurt. B. Determine the marginal profit from selling 4,000 containers of yogurt. And C. What is the selling price of a container of yogurt? I will read the question again, this time highlighting the important aspects. A yogurt company estimates that the revenue from selling X containers of yogurt is 4.5x. Its cost, C, in dollars, for producing this number of containers of yogurt is C of X equals 0.0001x squared plus 2x plus 3,200. It is important to make note of the fact that the revenue function is 4.5x, where x is the number of yogurt containers sold, and the cost function is 0.0001x squared plus 2x plus 3,200, where cost is in dollars and x is the number of yogurt containers produced. Part A asks you to determine the marginal cost of producing 4,000 containers of yogurt. Before you can start solving the problem, it is important to understand the vocabulary. First, revenue is the total income that a company receives after selling X containers of yogurt. Cost is how much money the company needs to pay to produce X containers of yogurt. Marginal cost is the instantaneous rate of change of the total cost after X containers of yogurt are produced, or the cost added by producing one more container of yogurt after X have been produced. Since the question requires you to determine the instantaneous rate of change, it is safe to assume that you will need to take a derivative of the cost function. Since the function is a polynomial and is not sinusoidal, exponential, or logarithmic, it is clear that this question comes from Chapter 2, Derivatives. Now back to Part A. Remember that the question requires you to find the marginal cost of 4,000 containers of yogurt. First, copy down the cost function so that you can differentiate it. Here is a picture of the cost function. Recall that the derivative of a function is the instantaneous rate of change of y with respect to x, or the slope of the original function at each value of x. Since this question asks you to find the marginal cost of producing 4,000 containers, it is asking for the slope of the cost function at x equals 4,000, or the slope of this tangential line. However, it is impossible to determine the exact slope of this line just by looking at the graph. Instead, you must find the derivative of the function, then solve for the marginal cost of producing 4,000 containers. Since the cost function is the sum of three terms, its derivative is the sum of the derivatives of these three terms, according to the sum rule. Therefore, we must first focus on differentiating the three terms separately. The first term is 0.0001x squared. Since this function has an exponent, the power rule is necessary to differentiate it. The power rule states that the derivative of any function in the form f of x equals x to the power of n is f prime x equals n times x to the power of n minus 1. Similarly, if the function has a constant and is in the form f of x equals a times x to the power of n, as this one is, its derivative is f prime x equals a times n times x to the power of n minus 1. Now it's time to apply this rule to 0.0001x squared. First, multiply by the exponent, which is 2. Then subtract 1 from the original exponent to determine the new exponent. The derivative of 0.0001x squared is 0.0002x. Now it's time to move on to the second term, 2x. This is a linear function, and its derivative can also be found using the power rule since x has an exponent of 1. Therefore, you can multiply the function by 1 and subtract 1 from the exponent to get x to the power of 0, which is equal to 1. The derivative of this term is 2. This makes sense because the function y equals 2x always has a slope of 2. The third and final term of the cost function is the constant 3,200. The graph of y equals 3,200 is a straight horizontal line. Since the function never increases or decreases, its rate of change is 0. Therefore, its derivative is 0. The derivative of the cost function is 0.0002x plus 2 plus 0, which simplifies to c prime x equals 0.0002x plus 2. To answer the question and determine the marginal cost of producing 4,000 yogurt containers, you must solve for c prime of 4,000 by substituting 4,000 in for x. The solution equals 2.8, which means that the 4,000th container of yogurt costs $2.80 to produce. Finish this question off with a concluding statement. The marginal cost of producing 4,000 containers of yogurt is $2.80 per container of yogurt produced. Now it's time to move on to Part B. Determine the marginal profit from selling 4,000 containers of yogurt. Make note of the fact that the question is asking for the marginal profit once 4,000 yogurts are sold. In order to determine the marginal profit, you need to find the derivative of the profit function. Profit is the company's financial gain and is the difference between the total revenue and the cost of yogurt production. Therefore, P of x equals R of x minus C of x. Since R of x and C of x are given in the question, you can proceed to derive the profit function. P of x is equal to 4.5x minus 0.0001x squared plus 2x plus 3,200. The next step is to expand the function by multiplying everything that is in the bracket by -1. Then collect like terms to get the profit function, negative 0.0001x squared plus 2.5x minus 3,200. The next step is to differentiate this function to find the marginal profit function. According to the sum rule and the difference rule, the derivative of the profit function will be equal to the sum of the derivatives of its first two terms minus the derivative of the third. Therefore, the easiest approach is to once again determine the derivative of each term individually. The first term, negative 0.0001x squared, can be differentiated using the power rule. It becomes 2 times negative 0.0001x to the power of 1, which simplifies to negative 0.0002x. The next term, 2.5x, can also be differentiated using the power rule, and it becomes 1 times 2.5x to the power of 0, or just 2.5. The final term, 3,200, is a constant. As determined in Part A, the slope of a constant is always 0. The marginal profit function is negative 0.0002x plus 2.5 minus 0, or just P prime x equals negative 0.0002x plus 2.5. To determine the marginal profit from selling 4,000 containers of yogurt, solve for P prime of 4,000 by substituting 4,000 in for x. The solution is 1.7. This means that the company profited $1.70 from the sale of the 4,000th yogurt container. A concluding statement is necessary. For example, the marginal profit from selling 4,000 containers of yogurt is $1.70 per container sold. Now you can move on to Part C. It asks, what is the selling price of a container of yogurt? The price is the amount of money that each container of yogurt is sold for. This can be determined by the revenue function R of x equals 4.5x, because the revenue function is equal to the price function times x. Therefore, if you factor x out of the revenue function, you are left with the price function in the brackets. 4.5x is equal to x times 4.5, so the price must be $4.50. Finish Part C with a concluding sentence such as the selling price of a container of yogurt is $4.50. And that is how you solve question number 8 on page 139. Any career which involves the sale of products may require you to solve problems such as this one. For example, the manager of a yogurt company would need to understand the problem in order to estimate their profit and determine their workers' salaries. That brings me to the end of my tutorial. I hope I have been able to further your understanding of taking derivatives and solving finance problems. Thank you for watching.